flower buds are probably sitting in your kitchen right now, but inside each one is a chemical with the power to number toothache, fight bacteria, and scent a perfume. That chemical is eugenol, and it makes up about 70 to 90% of clove oil. It's an aromatic compound with antiseptic, anti-inflammatory, and anesthetic properties, which is exactly why we would extract it for perfumes, mouthwashes, and even as a precursor to other chemicals. Now that we understand the principle, let me show you how we set up the distillation. All glassware was checked for cracks and cleaned before use. We crushed around 20 grams of clove buds using a mortar and pestle to increase surface area. Then added them to a 250 ml round bottom flask with enough distilled water to cover the cloves. The flask was then placed in a thermobile. A three-way adapter was connected to the flask and made sure the thermometer bulb was level with the side arm. To the side arm, we attached a condenser supported with a clamp and connected a receiver adapter to the condenser's end. The receiving flask was placed beneath to collect the distillate. Vacuum grease was applied thinly to the upper part of each male glass drain to create a good seal. Water tubes were connected in such a way that water entered the condenser through the lower inlet and exited through the upper outlet to the sink. Heating was then started. At around 100 degrees Celsius, distillation began. The distillation was continued until no more oil appeared in the distillate, and then the heat was turned off.
Sodium chloride was added to the distillate until saturated to force cleaner separation of eugenol-rich layer. The mixture was then poured into a clean separatory funnel and extracted 3 times with 10 ml portions of dichloromethane. DCM was chosen because eugenol dissolves readily in it, and since DCM is denser than water, it formed the lower layer each time. Between each extraction, we shook the funnel gently and vented frequently to release built-up pressure. The combined DCM extracts were dried by adding anhydrous sodium sulfate, which absorbed any remaining water. The mixture was then filtered through filter paper into a tiered evaporating dish. The dish was placed on a water bath at 60 degrees of Celsius to evaporate the DCM to obtain the pale yellow eugenol-rich oil layer. Troubleshooting and experimental difficulties occurred during the practical. First, the condenser clamp was initially placed incorrectly, trapping pressure inside the apparatus. During filtration, filter paper was mistakenly used instead of cotton wool, and then the water outlet pipe connected to the condenser broke during the experiment. Then the thermal well stopped functioning midway through the experiment and it emitted fumes, reducing the consistency of steam production and affecting the efficiency of oil extraction. So this is how each one of us contributed.